All right, folks, welcome back. Slowly making our way to inference. I have a couple of questions in the chat I want to go over. One person asks, say I have an experiment with 10 subjects that I did with analyze, I assume, with LMER. Now I have 20 subjects and want to use BRMS. Can I use some of the findings from LMER as priors? That's probably, I don't know whether Stefano and Joseph will agree with me, but I would say no, because your study with 10 subjects is probably severely uninformative, as we know with many of the variable effects we look at in speech. It's usually so heavily underpowered that the values that we get from that model are probably very off of the actual underlying true parameter values. So I would be very reluctant using data from a small study to feed into a later study. But it very much also depends on what you want to do, right? If you want to accumulate knowledge, accumulate cumulatively narrowing down estimates, then there's definitely use of, you can make use of these 10 subjects, of the data that you collect with the 10 subjects beforehand, so that we can use these as evidence in combination with the 20 subjects you ran later to approach a parameter value that is at least our best guess, given what we have observed so far and what model we used and what prior assumptions we have, right? But for generally, I think for now, we should, well, our recommendation is probably, let's be very, very careful with using any kind of informative priors, right? If this first study with 10 subjects gives you a rough idea of the quantitative system you're looking at, rough idea of what values are possible, then I'd say, yeah, they can inform you vaguely with regards to how you set the priors in the future if you didn't know anything beforehand. But when it comes to actual relevant parameters, like, for example, your predictors, I would be very careful, because small sample studies are known to have a very high false positive rate. They have a very high type M and type S error rate, meaning we grossly under or overestimate the parameters under investigation just because we have not enough data. But there's no true answer to this. So maybe Joseph and Stefano have different opinions on this matter. Speak up now.
I would just add that typically when you do this type of stuff, you don't want to peek at your data first. For example, like find out the mean of your outcome variable and then set that as your prior for the intercept, something like that. And using prior data from a pilot or something like that, and then fitting another model when you have more data, but it includes the previous data, kind of sounds like that. That seems like kind of data peaking, which is, in my understanding, is a no-no. So I would typically be very, very cautious, and I would avoid that specifically.
Yeah, that is what I was going to add. Like, based on the question, it seems that you originally had 10 subjects, and then you collected data from 20 new subjects, and you want to use just those 20 subjects. In that case, yes, you could potentially, in principle, use the knowledge that you gathered from the 10 subject pilot study. But as Timo was saying, very likely the estimates are like off because of the small sample size, right? But what Joseph was saying, you cannot look at the data and then use what you learned from the data to come up with priors. That's called double dipping, basically, where you, it's a technical term from the statistical sciences. It's where you basically peek at what the data looks like, and then you tell the model what you saw, and the model will just basically return what you told it, and that is not what we want to do. So double dipping is an issue. Perhaps if we have time at the end, I will briefly talk about sequential testing, which is absolutely a no-no in frequentist statistics, but can be done in Bayesian, in a Bayesian framework. So perhaps if we have time, I can say a few more words about that.
Yeah, thanks. There's one more question. What method can we use for power analysis before the experiment with Bayesian models? So power is not a concept in Bayesian world because we are not dealing with type 1 and type 2 errors, right? We're not looking at long run probabilities. If we would repeat the sampling procedure over and over again, this is not what we do here, right? What you probably tap into here is the question of, well, and that's the second part of the question, how do we know we will get useful answers? That's the really great question, right? How do we know we had enough data that the estimation that we make is, well, reliably close or reliable proxy to what is actually underlying this generative process so that we can do something with it, right? The usefulness of it. And there are ways to do that. They have to do with basically, it's very similar to power analyses in practice that you simulate a lot of data sets that have the properties that you're interested in, and you estimate what kind of posterior distribution you generate with these random samples, basically. So there are technically involved ways to do that. Power analyses and frequentist statistics is technically very involved as well, because not only technically, also conceptually, because you need to know a lot for power analysis to be useful, right? We throw that often around as an easy solution to some problems. It's not. Power analyses are non-trivial. They're really, really hard to do in a way that they're useful and accurate. And that is true for Bayesian sample size estimations as well. But they work similarly. It's just a difference in what we aim for. We're not aiming for reducing type 2 error rates. We are trying to increase certainty, decrease uncertainty.
Yeah, if I can add on that, the questions that we ask ideally are not, is there an effect or is there no effect? The questions that we are asking as researchers is, what is the effect? Whether it's 0, 1, 100, 1,000, that is what matters, right? With frequentist statistics, we have this idea that it's all about whether there is an effect or not, is about rejecting the null, but that is one way of doing research, right? You could potentially be interested in whether there is an effect or whether there isn't an effect, but most times we're interested in more than that. And then that's why the concept of power doesn't really apply to Bayesian, because power is related to significance, which doesn't apply to Bayesian statistics. And instead it's about getting a posterior that is as narrow. I always forget, like I always think of thin and then it doesn't sound right. Narrow. So you want the posterior to be as narrow as possible, basically, because that means that you're really certain at 95% confidence that the value based on the data and model lies within that range.
Just an add-on here. There's like it prosodically almost lost, but it's really important what Stefano said there in this de-accented, subordinate sense. Given the model, the data, and the priors. Because if your model is anti-conservative, for example, you don't take into account variation across group level effects, your posterior will be narrow because you're underestimating variability, right? So it's complicated. There are different ingredients. And I see in the chat a question, but any hint to estimate a reasonable sample size? There is no hint. It's a really involved process that requires simulating data. It's doable. It's not rocket science, but it's involved. And there are a lot of moving parts that we need to be aware of, and we can't cover that here. I think we should move on to...
Yeah, just very quickly, one hint would be that you need to know the size of the effect and you need to know the variation between participants. Once you know that, then you can run a power analysis. And most times we really know very little about those two things. But the hint would be knowing the size of the effect and knowing the expected variation in the effect, which defines the purpose of doing a power analysis. Because you want to estimate something, but you need to know about that in order to do a power analysis. But that's how it works.
Right. Okay, guys, we will do some